So when you're looking at the following types of polynomials that have been factored, these are the types that you did in the previous lesson. Did anyone find the more efficient or quicker way to factor these binomials? Hopefully what you've noticed is a couple patterns to them. All of the answers have one minus and one positive. This one here is a little bit unique, so you're going to go, they're both positives. Let's look at the question. If we rewrite it, each of these get rewritten, and then we have 1 minus and 1 plus. 1 minus, 1 plus. 1 minus, 1 plus. It holds true in all of these examples. So that's one thing that we will notice, and it should make sense because when you are multiplying to get that last term, in each case all of these had a last term of minus. So you need a positive times a negative to give us that negative. So that was one thing you should have noticed. What else did you notice? Let's look at the relationship between the first term in the polynomial and the first term in each factor. Do you see a relationship? Hopefully, you have noticed that the first term in each factors, the first term in each bracket, are all the same, and that they are the square roots of the first term of the polynomial. Square root of 81 is 9. Square root of 9d squared is 3d. Square root of 64g squared is 8g. Square root of x squared over 16. Square root of x squared is x. Square root of 16 is 4. So we square rooted the first term. Look at the relationship between the last terms. Hopefully you recognize it's the same. They've been square rooted. Square root of 4b squared is 2b. Square root of 16f squared, 4f. Square root of 36t squared, 6t. These types of polynomials are called difference of squares. So if we consider x squared minus 25, we can write x squared minus 25 as x squared minus 0x minus 25. And that's when we used the box method. If you will look for two integers whose product is negative 25 and whose sum is 0, they are 5 and negative 5. So x squared minus 25 is x minus 5 and x plus 5. So we did that using the box method. But there is a quicker way, and that is understanding that they are difference of squares. So really, all you need to do, square root the first term, start each parenthesis or each factor. Square root the second term, end each factor, make one a negative, one a positive. And you have your answer. So those are called difference of squares. Both terms are perfect squares, and they are called a difference of squares because this only works if they are separated by a negative sign. They are separated by a positive sign. They are not a difference of squares. In your practice today, you're going to put together the last 3 lessons. So we used the box method the first day where the coefficients of the square term were 1, and there was a shortcut to that. If you remember it, go ahead and use it. Otherwise, you can use the box method. The second day was simply using the box method. And the third day, we used the box method, but there was a shortcut for difference of squares. So on the assignment today, you could do every question using the box method, or if you recognize shortcuts for some of them, feel free to use the shortcuts.